recorded. Our today's class, we will discuss about a topic that is called CPU scheduling. What does scheduling means? That whenever we have multiple processes, the operating system have multiple processes, it has to decide which task it will do first, okay, or how it will do handle multiple tasks. Will it handle one at a time, or it will handle multiple tasks at a time? Whether it will finish one task then go for another task, whether it will do a part of one task then go to another task and then go to another task in this way, whether it should focus on the priority or the one that came first, and so on. So there are a lot of complicated issues that we have to the operating system have to actually go through, and the same way the operating system has to make complicated decisions as well to make sure that the overall performance of your computer is actually a nice one. Okay, that means you don't have to wait too long for anything. Okay, you don't have to wait for response from the user, you don't have to get wait too much for getting result from the computer, and so on. So basically CPU scheduling is a set of algorithm, okay, that the operating system use to decide how to actually handle multiple processes, how to actually process them, how to allocate CPU among multiple processes. So here is a picture that you are seeing in the screen. What does this picture actually depicts? That we have a CPU, this is the CPU, okay, and this is our ready queue where we have multiple processes. Now each process has different amount of tasks. Okay, some of have IO request, they need to give input outputs. Okay, some of them have actually have forked a child, that means they have created a new child. Some of are waiting for some of them are waiting because of an interrupt, and so on. So there are many things that can happen. And there is another thing that we haven't discussed, that is time slice expired. What does this mean? That you have allocated a process, a program 5 minutes of the CPU time, and the 5 minutes is over. So there are many other reasons, various reasons for which a process that was in the CPU, okay, the diagram starts from here. You have a CPU, and from that CPU, for these reasons, one, IO request, okay, input output request, or maybe time slice expired, or a fork a child, okay, created a child and the child is executing, or maybe there was an interrupt and it is due to interrupt it is waiting. So all this reason, a process can go from this CPU to go back to at the beginning of the ready queue. So for various reasons, a process can go back to the ready queue. Okay, now what is our what is the challenge here? That once a process go back to the ready queue, the CPU has to decide that how to actually take it back, or which process should actually given a priority, or given access to the resources that you have in your computer. That resource might be your input output devices, the resource might be your processing power, or the resource might be any type of hardware, okay, like a clock time, okay, and so on. So again, in short, CPU scheduling are set of algorithms that the operating system uses. Why? To make decision that to which process or which task it should do first, or to whom it should allocate the resources it has. Okay, now this can be done between the threads or processes. So a thread is basically a collection of instructions as well. So basically you can assume that this is a process. Okay, now there are some assumptions that we have in the scheduling algorithms. Before talking about these assumptions, one thing I want to say that so far we have actually, if you see that in the chapter 1, 2, 3, 4, what we did, we actually studied about some of the topics. We studied about what is IO request, how your operating system handles this IO request. Okay, we have talked about what is a child, what is a parent process. Okay, what are the things we need to be, how should I put it? What are the things we have to be careful, the resource need to be considered whenever we are treating a child, just like sharing the memory location, sharing the resources, and so on. Okay, between parent and child process. And there's a example we have talked about, that given you and your father sharing the same account, or your father allocating a specific amount of money to a certain account, or the father giving you all the money, and so on. Okay, and then there is the cause of interrupt. We have studied what is interrupt, why interrupt occur, okay, what are the reasons of interrupt, how the interrupt is handled, okay, and so on. So we have talked about this, and we haven't actually got introduced to time slice expiration that much. The basic idea is very simple for this one, that sometimes whenever we are working with a CPU, instead of we actually allocate our process a certain time, that hey, if you want to do your task, you have 5 minutes, and if you can do that within that time, that's fine, otherwise you have to finish. Okay, so that is basically called time slice expired. And for all these reasons, we have learned about all this, we have actually talked about all this, so we actually have an idea about how all, where, in which situation all this might happen. Okay, now we will see the next case, that there are some implicit assumptions we have in terms of CPU scheduling. You know, this is a big research area in the early 70s. The importance, I can go on for like 2-3 minutes, but I will just show you two examples in upcoming slides, and that will make things more clear for you. Now, first of all, one program per user. So this is actually talks about that in a CPU, whenever you are actually using, let's just use one program at a time, because obviously as a human we cannot use multiple programs at the same time, because in the screen you can see only one. Okay, but now you will say, sir, I can actually listen to music and I can study at the same time, so basically I'm using multiple program, right? Yeah, that's it. So that is the reason this actually doesn't work, because people want to use multiple programs at the same time. Okay, another thing is that if you actually like let's assume that you are downloading something in the background, you just want to just open the download and just wait for until the download is finished, right? This happened in the old days when I have, you know, I had a internet connection of 5 kilobyte per second. Can you imagine nowadays? Okay, I had to actually, whenever I downloaded something or went to a website or anything, I had to like wait. Okay, just click it and wait, and meantime I had to make sure that no one else was using the internet. Okay, or maybe I was not using the internet in other tabs. So that was the time. But now the internet is very fast, you can do multiple tasks at the same time, so this doesn't actually work. Then one thread per program, this is almost same as this, that for one program, okay, one set of program, you can have multiple instances. Like if you think about Google Chrome, okay, if you want turn on your Google Chrome, run your Google Chrome, you can actually use it multiple tab. In one tab you can use Facebook, in another tab you might have a YouTube video that is playing, okay, then in another tab, okay, you might have doing some other things. Okay, so this doesn't work as well. One second. So you, as I was saying, that you don't have to, you can actually use the same one program. You can have multiple threads or multiple instances going on at the same time. And the third one, the programs are independent, which is also not true. One simple example that I can give you right now is that, you know, right now you're using, let's assume, the Zoom app. Okay, and in the Zoom app, what you are actually doing? Okay, first thing you are, uh, you know, first thing is that what you are doing, um, one second. So the Zoom app, whenever you're using it, okay, what you are doing actually, you are first using the Zoom app, you're running the application. In the background, what's happening, that every time I am actually speaking something, okay, it's actually getting processed. My audio is getting processed and being sent to your via internet to all of your devices, so you can actually listen to it within a second, within a distance of second. You see, doesn't matter whether you are where you are in the country. Okay, just within a few seconds of time, whatever I am speaking, okay, that means the input output devices working in the background, they are processing the input. The same time you can see it on the monitor, the slides I am showing. So that means the video is also working on the background. The internet connection, that means sending data, receiving data, also working on the background. And finally all of them are combined to Zoom app. So basically what I'm trying to say, that no apps are actually independent. Each program actually use other programs. Right now, if you go to your task manager, you will see that a lot of other programs are running on the background. Okay, so these are actually some of the things that make it actually more complicated. Then one thing, that what is actually our goal, or the goal of this chapter? We actually want to actually learn how CPU actually schedules everything so that the time scheduling is actually optimized. Okay, and the parameters are also optimized. Now we will learn about the parameters as well. There's one last thing I want to talk to you about this slide, is that the fairness among users and program. So what does this mean, fairness among users and program? So basically, whenever you are actually running a program, okay, let's first talk about the users. You will understand this better. So if you have multiple users, let's assume 5 people are using the computer. Okay, now what can you do? There is one thing you can do, that okay, the first person who started it, he'll use it until he is finished, that no other person can use it. Then the second person will use it, then the third person, then the fourth person, and the fifth person. So basically, if 5 people wants to use a computer, the person who started using it first will use it. Then after he's finished, the second person will use it, then the third person, then the fourth person, and the fifth person. This can be one kind of rule. Another can be that, okay, first person is using it for 10 hours. Should I wait for 10 hours? Okay, let's make another rule. I'm here for only 10 minutes of work. So person 2, he just needs 10 minutes of work. So what you can do, you can say, okay, everyone will use it for 1 hour. So person 1, you can use it for 1 hour. Person 2, you're using it for 1 hour. 3, you are using it for 1 hour. Person 4, you are using it for 1 hour. Person 5, you are using it for 1 hour. Okay. So what about next? What another solution can be? Another solution can be is this, that you see, person 1 has actually a very important task to do, but person 2 is actually just wants to play game. Person 3 wants to listen to music. Person 4 maybe wants to do another important task. So what you can do, you can actually give priority to the people who has the actually most important task. So if person 1 has important task, he will go first, then person 2, person 3, and then 4 and 5. So what I have shown you is 3 things. First one was this one, where whoever started first used computer first. Just like I came first, I will get this first. Okay. Second one was that I allocate everyone a specific amount of time. Okay, and third one is basically based on priority. So these are the different ways you can actually make things fair. That means everyone will get it as they need it. Okay, but even though you try out many possible options, okay, sometimes the situation actually differs. Okay, because if I talk about this one, everyone will use it for 1 hour. It might sound very fair, right? Because you have it 1 hour. But what might happen that you actually are trying to do an assignment that you have to submit tomorrow, and you are actually competing with your brother who is just want to play games. So your 1 hour you are doing assignment, next 1 hour he is playing games, and then again 1 hour you are doing assignment, next 1 hour he is playing it. So this doesn't seem fair to you, right? You have an important task to do. Okay, so same way, actually different algorithms have some pros and some cons. So some of the algorithms, that scheduling algorithms we will use, will be fair to some of the cases. So we call it job. Okay, so these jobs that we will schedule, okay, the process that we will schedule, sometimes it will be fair to the user will get the benefit. Sometimes it will be fair to the programs, but the computer actually doesn't care about the programs, right? The computer is here to make sure that you're as a user, you are actually comfortable. Okay, so we'll talk about this more. So this is our goal. Okay, we will decide what are the parameters, whether we want to make it optimized, like what is the definition of optimization, that I can use it as fast as possible, everyone is fair, and so on. So these are some of the questions that we have to actually answer. Now, I will come to this later. So what is important in a scheduling algorithm? Let's, without going through the details, let's first go here. So the 3 things. First of all, minimize response time. Second of all, maximize throughput, and third is fairness. So basically, this is already I have talked about. We will share CPU among users in some equitable way so that everyone actually gets what they need. Okay. Then what is response time? Response times means that whenever you're actually giving input, or whenever you're actually giving a command to your operating CPU, okay, it actually reacts to it. Okay, let's assume you're typing something. Okay, so if you type something, you have to instantly see it, right? Otherwise, it just feels odd. Just think about a mobile phone that hangs a lot. Okay, you are giving, pressing something, but nothing is showing. Then after a little bit, lot of inputs. Another example can be, those of you who have a low amount of RAM, you might face this in your Google Chrome or Mozilla Firefox browser, that you turn on your computer, you press Google Chrome, nothing opens. Okay, you think, okay, I might have mispressed. Okay, you press again, you press again, you press again, and after a certain amount of time, 10 Google Chromes open up. Okay, surprise. But what happens? The response time was not good, right? So you want to respond it to exactly same amount of time. Second one is throughput, that yes, you have a good response time, but the throughput is not good. What does throughput means? That if you give it some task that, hey, do this calculation, add this two number, okay, what happens that it actually, okay, I'm doing the calculation, see you after 1 hour. Okay, so like it takes a long amount of time to do simple tasks, okay, or maybe some complicated tasks. So the throughput is that the jobs per second, that how many instructions or how many commands you are actually doing in a specific amount of time. Okay, so this is actually called throughput. So we are actually trying to actually minimize response time. So that means the computer will respond as soon as possible. We want to maximize throughput, that it will do as much as task as possible. And finally, fairness. All the users will actually get equitable share as they needed. So this is some important parameters that we are actually trying to find in our scheduling algorithms. So let's talk about the algorithms now. Okay, so before going to the algorithms, we'll first start with the concept of first come first serve. What does this mean? So basically this means that if you want to get a service, okay, if you go first, you will get first, just like a ticket or any other lines. Whoever comes first gets service first. You are learning queue in your data structure course. Those of you have already done it, you already know that how queue works. So this is first in first out approach. Okay, and CPU also use a very basic queue. So if you have already learned queue, you already have no part of operating system. Okay, you will understand part of the operating system code. Congratulations. Now, so the first concept is first in first out algorithm. So basically the process which comes first gets first.